September 1942. Ypsilanti, Michigan. Dawn broke cold across the concrete, and the B-24 Liberator trembled on the runway as test pilot Robert Johnson climbed into the cockpit. 4 Pratt & Whitney R-1830 engines, 36,000 pounds of aluminum and steel, 67 feet from nose to tail, a wingspan stretching 110 feet. Behind him, through the morning mist, stretched the longest assembly line he'd ever seen, over a mile of machinery and workers, a river of industrial power flowing through what had been farmland just 18 months earlier. Johnson's hands moved through the pre-flight checklist with practiced efficiency. Fuel mixture, magnetos, oil pressure, hydraulic systems. The B-24 was a complex machine, far more sophisticated than anything he'd flown in civilian aviation. 4 engines meant 4 independent systems to monitor. Twin-tail configuration changed the handling characteristics. The tricycle landing gear was revolutionary but unfamiliar. Every system had to function perfectly, or 36,000 pounds. A bomber wouldn't leave the ground, or worse, wouldn't come back down safely. He wasn't thinking about history. He was thinking about hydraulics that might fail, flaps that might jam, engines that might quit. The 1,000 technical details that separated a successful test flight from a smoking crater. But history was happening anyway, whether he acknowledged it or not. This was Willow Run, Ford Motor Company's massive aircraft factory, and the plane beneath him was one of the first complete B-24 Liberators to roll off Henry Ford's assembly line. The same company that had revolutionized automobile production was about to do the same thing with 4-engine heavy bombers. The irony wasn't lost on anyone paying attention. 2 years earlier, aircraft industry experts had dismissed Ford's ambitions as fantasy. You couldn't mass-produce bombers the way you mass-produced cars. Aircraft were too complex, too many variables, too much precision required. The tolerances were measured in thousandths of an inch. A single misaligned component could mean catastrophic failure at 20,000 feet. The experts said it couldn't be done. Johnson advanced the throttles. The engines roared to life, and the Liberator began rolling down the runway. Behind Johnson, through the factory windows, 42,000 workers were building the future. Women in coveralls operated rivet guns. Former farmers welded wing sections. Teenagers fresh out of high school installed hydraulic systems. They worked in shifts around the clock, 365 days a year, transforming raw aluminum into aircraft at a pace the world had never seen. This was America's answer to a question nobody thought needed asking. Could a nation still recovering from the Great Depression? A nation that ranked 18th in military power in 1939 outproduce the combined industrial might of Germany and Japan? Could democracy's factories defeat dictatorship's armies? The challenge seemed impossible for concrete reasons. In 1939, America's active military numbered about 330,000 soldiers. Germany had mobilized more than 4 million. Japan's military exceeded 5 million. The gap wasn't just numerical, it was philosophical. Totalitarian regimes had spent years orienting their entire economies toward war production. Every factory, every resource, every worker. Germany had been building tanks, aircraft, and artillery since Hitler's rearmament programs began in the mid-1930s. Japan had been on a war footing since invading China in 1937. America, by contrast, was still emerging from the worst economic collapse in its history. Unemployment remained high. Industrial capacity existed, but it was oriented towards civilian production. Converting a factory that built refrigerators into one that manufactured aircraft components wasn't simple. It required new tooling, new workforce training, new supply chains, new quality control systems. The transformation demanded technical expertise, organizational capacity, and capital investment on a scale never attempted. Consider the specific technical challenges. An automobile engine had perhaps 200 precision parts. A single Pratt & Whitney R-1830 aircraft engine contained thousands of components, each manufactured to tolerances far tighter than anything required in automotive production. A car's structural integrity could tolerate minor variations. An aircraft at 20,000 feet, subjected to extreme temperatures, vibration, and stress, required perfection. One failed bearing, one cracked cylinder, one loose connection. Any of these could mean a bomber plunging from the sky with 10 men aboard. The answer was forming on the runway beneath Johnson's feet. The answer was roaring to life in factories across America. The answer would be written in aluminum and sweat and 24-hour shifts. Over 4 years, American industry would produce 304,000 military aircraft, more than Germany and Japan combined. More than anyone thought possible. More than Hitler's advisors believed when they dismissed Roosevelt's production goals as propaganda. And it all began with a promise that sounded like madness. May 1940, the world was falling. France was collapsing under the weight of German blitzkrieg. The British Expeditionary Force was being evacuated from Dunkirk's beaches, leaving behind nearly all its heavy equipment. The German war machine, which had swept through Poland in 27 days and shattered French defences in 6 weeks, seemed unstoppable. The Maginot Line, that symbol of French defensive power, had been bypassed and rendered meaningless. Britain stood alone, facing an invasion that German planners were already organising. Operation Sea Lion, the conquest of Britain, the end of European democracy. In Washington, President Franklin Roosevelt understood what many Americans did not. This was not Europe's war. This was not some distant conflict that would resolve itself regardless of American involvement. This was the future arriving ahead of schedule, and America was catastrophically unprepared. The comfortable assumption that 2 oceans would protect American security was obsolete. Modern aircraft had changed warfare's fundamental mathematics. Distance no longer guaranteed safety. The numbers told a brutal story. In 1939, American military aircraft production totaled fewer than 3,000 planes. Many of these were trainers or obsolete designs unsuitable for modern combat. The Army Air Corps possessed only a few hundred combat-ready aircraft. By comparison, Germany entered the war with approximately 4,000 frontline combat aircraft. Their pilots had been trained in Spain during the Civil War. Their tactics had been tested in Poland. Their production capacity had been expanded systematically since 1935. The industrial capacity to build modern weapons existed in America, but it was scattered, unfocused, oriented towards civilian production. The automobile industry built millions of cars annually, demonstrating manufacturing capability that no other nation could match. But converting that capability to military production wasn't automatic. It required coordination, investment, technical expertise, time. And time was the resource in shortest supply. Roosevelt faced a population that remained deeply isolationist. The First World War's slaughter had convinced many Americans that European conflicts should remain European problems. The Depression had focused attention inward. American families struggling with unemployment and poverty saw European wars as distant abstractions. Convincing them that defense production was necessary required confronting their assumptions about America's security. Meanwhile, Germany had been building its war machine for years. By 1940, German factories were producing aircraft by the thousands, supported by an entire economy oriented toward military conquest. The Messerschmitt Bf 109 had been refined through combat experience. The Heinkel He-111 bomber was proven and reliable. The Junkers Ju-87 Stuka dive bomber had terrorized Polish and French defenders. German industry didn't need to be converted to military production. It was already there. Japan's industrial base, though smaller than Germany's, had been mobilized for war since the mid-1930s. Their invasion of China in 1937 had provided combat testing for aircraft and tactics. Japanese Zero fighters were proving superior to every fighter the Allies could field in the Pacific. Their bombers were long-range and effective. Their industrial capacity was growing, and their military controlled the government, ensuring that economic resources flowed toward military production. Against this, America had potential, vast potential. But potential isn't weapons. Potential doesn't defend airspace or support ground troops. Converting potential into actual military power would require transforming the entire industrial economy. Fast. Roosevelt stood before a radio microphone on May 26, 1940, preparing to make a request that would transform America. He asked Congress for funding to produce 50,000 aircraft per year. Not fighters alone, not trainers or reconnaissance planes, combat aircraft, bombers, attack planes. The tools needed to fight a modern war. The reaction was immediate and skeptical. Critics called him crazy. Aviation experts declared it impossible. German intelligence dismissed it as American propaganda. They had reason for doubt. Producing 50,000 aircraft per year would require a complete transformation of American industry. It would require training hundreds of thousands of workers in skills they'd never needed. It would require converting automobile plants, furniture factories, even textile mills into precision manufacturing facilities. It would require solving engineering problems that didn't yet have solutions. But Roosevelt had seen something others had missed. He understood that America's greatest weapon wasn't its army or its navy. It was its industrial capacity. The same factories that had built 15 million Model T Fords, the same assembly lines that had made automobiles affordable for ordinary Americans, could be redirected toward producing the machines of war. The same engineering expertise that had created the American consumer economy could be focused on military production. The question wasn't whether America could outproduce its enemies. The question was whether American industry could transform itself fast enough. Charles Sorensen understood this immediately. As Ford Motor Company's vice president of production, Sorensen had spent decades perfecting mass production techniques. He understood manufacturing at a level few people in America could match. He knew what was possible and what wasn't. He knew the difference between optimistic projections and achievable reality. In January 1941, he traveled to San Diego to visit Consolidated Aircraft's factory, where they built B-24 Liberators using traditional aircraft production methods. What he saw horrified him from an industrial efficiency standpoint. Workers assembled planes individually, fitting parts by hand, making adjustments as they went. Each aircraft was essentially custom-built, with craftsmen solving unique problems for each bomber. The techniques would have been familiar to workers building biplanes in 1920. They were meticulous. They were careful. They produced high-quality aircraft, and they were completely inadequate for the production scale Roosevelt demanded. Sorensen watched men assembling wing sections outdoors, exposed to California's temperature variations. Metal expands and contracts with temperature changes. The fixtures they used to hold components during assembly distorted in the heat, shifting by fractions of an inch. That meant constant readjustment, recalibration, rework. The same wing assembly process performed in morning. Cool produced different results than the identical process, performed in afternoon heat. He watched workers hand-fit, parts that should have been interchangeable. Why didn't the parts fit precisely? Because traditional aircraft production accepted minor variations. A skilled craftsman could make adjustments, file a mounting bracket here, ream a hole slightly there, shim a joint. The craftsmanship was impressive, but it was slow. It required skilled labor. It couldn't scale. Sorensen understood immediately that this approach wouldn't work. Not for 50,000 aircraft per year. Not for the production levels Roosevelt demanded. Not for the war that was coming. You couldn't hand-fit 50,000 aircraft. There weren't enough skilled craftsmen in America. Training them would take years. By the time they were trained, the war might be lost. That night, in his room at the Hotel del Coronado, Sorensen couldn't sleep. The magnitude of the challenge consumed his thinking. How do you mass-produce something as complex as a 4-engine bomber? The B-24 wasn't a car. It was far more complicated. More components, tighter tolerances, harsher operating environment. But the fundamental principles of mass production were universal. They had to be. He spread papers across his desk and began sketching. Not a factory, a system. A comprehensive manufacturing system that would transform aircraft from custom craft to mass-produced goods. The key insight was modular thinking. The B-24 wasn't one impossibly complex machine. It was a collection of subassemblies, wings, fuselage sections, tail assemblies, engine mounts. Each subassembly could be manufactured separately, brought to precise specifications, then integrated on a final assembly line. The breakthrough was standardization. Every part manufactured to tolerances so precise that any given component would fit any aircraft. No hand-fitting, no craftsman adjustments, just precision manufacturing and systematic assembly. It meant revolutionizing tooling, creating fixtures accurate to thousandths of an inch, developing quality control systems that could verify precision at every stage, training workers in specialized tasks rather than general craftsmanship. Sorensen sketched a mile-long assembly line where B-24 bombers would move continuously from raw materials to finished aircraft. Sub-assemblies would be manufactured in parallel, timed to arrive at the main assembly line exactly when needed. Workers would perform specialized tasks repeatedly, developing expertise and speed. The moving assembly line would maintain continuous flow, eliminating delays and bottlenecks. By morning, he had created a rough outline of Willow Run, a factory that would become the largest manufacturing facility under one roof in the world, a facility that would employ more than 42,000 workers at its peak, a facility that would prove mass production could build anything, even 67-foot four-engine heavy bombers. The skeptics were numerous and vocal. North American Aviation's president, Dutch Kindleberger, famously dismissed Ford's plan. "You can't expect a blacksmith to make a watch overnight." The comment captured the aircraft industry's prevailing attitude. Aircraft production was specialized work, requiring specialized skills. Mass production techniques worked for simple products like automobiles. But bombers, that required craftsmanship that couldn't be systematized or standardized. Each B-24 contained 450,000 parts. It required 360,000 rivets in 550 different sizes. It weighed 18 tons. Compare that to an automobile, which had 15,000 parts and weighed about 3,000 pounds. The complexity seemed insurmountable. But Sorensen and Ford had learned something from decades of automobile production. Complexity could be managed through systematization. Break the aircraft into subassemblies. Manufacture each subassembly to precise specifications. Train workers in specialized tasks. Create fixtures that ensured consistency. Use the moving assembly line to maintain continuous flow. The principles were universal. The scale was merely different. Construction of Willow Run began in March 1941. Architect Albert Kahn designed a facility covering 3.5 million square feet. The main assembly line stretched over a mile, featuring 4 massive turntables that allowed the production line to make 90-degree turns. This wasn't just about space. The L-shaped configuration allowed the plant to span 2 counties while keeping taxation manageable and avoiding the airport's taxiways. The construction itself was a marvel. Workers built the factory in sections using plywood partitions to seal completed areas from those still under construction. Parts of the plant began production in September 1941. Even as construction continued elsewhere, the race was on. Pearl Harbor was still weeks away, but the urgency was building. America needed aircraft, thousands of them, tens of thousands, and they needed them soon. The first challenges emerged immediately. Consolidated Aircraft, the B-24's designer, had no blueprints for Ford to work from. They had sketches, drawings, templates, the tools of custom fabrication, not mass production. Ford engineers had to reverse engineer the entire aircraft, creating precise technical drawings that could be used for mass manufacturing. They had to redesign parts for easier production. They had to create fixtures, jigs, and tooling that didn't exist. Then came the labor problem. Able-bodied men were being drafted or volunteering for military service. The factory was 40 minutes from Detroit, and wartime gasoline rationing made commuting difficult. In 1 month, Ford hired 2,900 workers but lost 3,100. The turnover was staggering. Training costs soared. Quality suffered. The production numbers Roosevelt had promised seemed increasingly fantastical. Ford's solution was revolutionary for 1942 America. They began hiring women. Not just a few women for administrative roles or light assembly work. Thousands of women for factory floor positions that had always been considered men's work. Heavy machinery, rivet guns, welding equipment, hydraulic systems. By May 1942, 15% of Willow Run's workforce was female. They earned the same wages as men for the same jobs, 93 cents per hour for rivet transport, higher for skilled positions. This represented a radical departure from standard American employment practice. These weren't just workers filling temporary gaps. They were pioneers dismantling assumptions about gender and capability that had structured American society for generations. The cultural resistance was substantial. Many male workers resented women on the factory floor. Supervisors doubted women could handle the physical demands. Society questioned whether women should be doing men's work at all. The skepticism was pervasive and explicit, but necessity overwhelmed prejudice. The war demanded aircraft production at unprecedented scale. Male workers were being drafted. The labor shortage was acute and worsening. Companies either hired women or failed to meet production quotas. The choice was stark and simple. Roswell Monroe embodied this transformation. A young woman from Pulaski County, Kentucky, Monroe had never seen an aircraft factory before the war. She'd never operated industrial machinery. She'd never imagined working in heavy manufacturing. But in 1942, she traveled to Michigan and took a job at Willow Run building B-24 bombers. The pay was better than anything available in Kentucky. The work was hard but satisfying. She learned to operate rivet guns, install components, and perform quality inspections. Monroe wasn't unique in background, but she became symbolically important. When a filmmaker visited Willow Run looking for subjects for promotional films, Monroe's competence and personality caught his attention. She appeared in recruitment films encouraging other women to join defense work. Her name, Rose, aligned perfectly with the popular song Rosie the Riveter that had captured America's imagination. She became a symbol, but she remained real. One of hundreds of thousands of women proving that capability had nothing to do with gender. The statistics documented a revolution. By November 1943, aircraft industry employment peaked at 2.1 million workers nationwide. More than 486,000 were women, 37% of the industry's total labor force. Compare this to 1939, when women represented less than 1% of aircraft industry workers. The transformation was total and unprecedented. These women operated complex machinery that most men had never seen before the war. They read technical drawings requiring spatial reasoning and precision interpretation. They assembled hydraulic systems with dozens of components that had to interface perfectly. They installed electrical systems where one misconnected wire could cause catastrophic failure. They worked with pneumatic tools that delivered thousands of pounds of force. They welded structural components where joint strength was literally life or death for air crews. Marie Kolk walked into the Glen L. Martin, Nebraska company plant in Omaha on October 20, 1941. She was 26 years old. She'd never worked in a factory. She'd never imagined working on an assembly line building bombers. But she needed a job, and Martin was hiring. She became one of 19 women who started that day, weeks before Pearl Harbor brought America into the war. Kolk learned riveting first. The pneumatic rivet gun weighed 15 pounds and delivered rapid-fire impacts requiring strength and precision. Too little pressure and the rivet wouldn't seal properly. Too much, and you'd damage the airframe. The technique required feel, timing, and endurance. 8-hour shifts, 10-hour shifts during peak production, 6 days per week. The physical demands were brutal, but Kolk and her co-workers proved equal to them. The social dynamics in these factories were complex and revealing. Many women discovered capability they'd never been permitted to demonstrate. Housewives, who'd been told their proper sphere was domestic, found themselves operating lathes and milling machines. Farm girls accustomed to physical labor adapted quickly to industrial work. High school graduates fresh from commercial classes learned technical skills their education had never contemplated. Sybil Lewis, an African-American woman who worked at Lockheed's plant in Los Angeles, described the transformation years later. You came out to California, put on your pants, and took your lunch pail to a job. You worked in the factory. You taught your kids to play baseball or something. You became a member of the community. You could go to the bank and cash a check. You could write a check. You weren't looked down on because you were a domestic worker. You were somebody. The training infrastructure expanded to match the need. Ford's Aircraft Apprentice School trained up to 8,000 students per week, teaching specialized skills required for aircraft production. These weren't 4-year engineering programs. These were intensive courses designed to turn ordinary people into capable workers in a matter of weeks. The programs taught riveting techniques, demonstrating proper tool operation and joint inspection. They taught welding, covering both technique and metallurgy. They taught blueprint reading, enabling workers to interpret complex technical drawings. They taught hydraulic systems, electrical systems, sheet metal work, all the specialized knowledge required for aircraft assembly. Women learned alongside men in these programs, often outperforming their male counterparts. The instructors discovered something the traditional education system had missed. When properly trained and motivated, women were just as capable as men in technical fields. The wartime emergency forced a discovery that peacetime prejudice had prevented. The factories adapted to accommodate women workers. Douglas Aircraft built daycare centers adjacent to their Long Beach plant, so mothers with young children could work defense jobs while their children were cared for nearby. Lockheed opened satellite plants in suburban areas, Santa Barbara, Bakersfield, Fresno, specifically to attract women workers who were less comfortable commuting into urban industrial centers. Some factories adjusted shift schedules to accommodate family responsibilities. Others provided shopping facilities and banking services so workers could complete errands without taking time off. These adaptations weren't purely altruistic. They were recognition that women workers were essential and that supporting them was necessary for maintaining production. But the effect was real. Women gained economic independence, technical skills, and confidence that peacetime society had systematically denied them. The learning curve was steep and painful. Quality problems plagued early production. Parts didn't fit properly. Assemblies required rework. The Army Air Force inspectors rejected aircraft that didn't meet specifications. Ford's production chief, Charles Sorensen, protested that continuous design changes made mass production impossible. Every modification required retooling, new fixtures, retraining workers. The assembly line's efficiency depended on standardization, but the military kept demanding improvements based on combat experience. The solution emerged through cooperation. Willow Run would focus on building B-24s in stable configurations, minimizing assembly line disruptions. Completed aircraft would fly to modification centers where specialized crews would install the latest upgrades, customize planes for specific theaters, and incorporate lessons learned in combat. This compromise allowed Ford to achieve the production efficiency mass manufacturing required, while still delivering aircraft with the latest improvements. By 1943, the system was working. The bugs had been resolved. Workers were trained and experienced. Supply chains were established and reliable. Subassemblies arrived from nearly 1,000 Ford factories and independent suppliers, flowing into Willow Run's assembly line in precisely timed sequences that would have seemed impossibly complex just 2 years earlier. The central wing assembly, which had been a major production bottleneck in 1942, exemplified the transformation. This wasn't just a wing, it was the structural heart of the B-24, the component that held everything together. The center section housed fuel tanks, connected the outer wing panels, and provided mounting points for landing gear and engine nacelles. Getting it wrong meant a bomber that might break apart under stress. Getting it right repeatedly and precisely required manufacturing, capability that pushed the boundaries of American industrial technique. Ford engineers had developed a multiple-function machine that could complete 42 precision machining operations on the center wing assembly to tolerances of 0.002 inches, 2/10,000ths of an inch, in just 17 minutes. Think about what that means. 42 separate machining operations, each requiring positioning, cutting, and verification, all performed with precision measured in millionths of inches. Completed faster than most people could drive across town. This wasn't just speed, it was systematic precision. Every center wing assembly emerged identical to the last, manufactured to specifications so exact that parts were truly interchangeable. A wing spar manufactured on Monday could mate perfectly with fittings manufactured on Friday. No hand fitting, no craftsman adjustments, just precision manufacturing and systematic assembly. The production numbers began climbing in ways that vindicated Sorensen's vision. In August 1944, Willow Run produced 428 B-24 Liberators. That's more than 14 per day, every day, for an entire month. But even that understated the achievement. The highest single production period saw 100 completed bombers flying away from Willow Run. Between April 24th and April 26, 1944, 104-engine heavy bombers in 3 days. Consider what that required. Each B-24 contained 450,000 parts. That's 45 million parts in 3 days. Each one had to be manufactured, transported to Willow Run, stored, retrieved at the right moment, and installed correctly. The logistics were mind-boggling. The coordination required hundreds of planners tracking thousands of components moving through hundreds of facilities. By 1944, Ford was producing one B-24 every 63 minutes, 24 hours a day, 7 days a week. The pace that Sorensen had sketched in his hotel room 3 years earlier had become operational reality. Workers on different shifts never met, but maintained the same production rhythm. Quality inspectors verified every critical component. Test pilots flew newly completed bombers, from Willow Run's runway to modification centers where they'd be fitted with the latest equipment. Before being shipped overseas, the human element of this achievement deserves emphasis. This wasn't robots or automation. This was people, many of whom had never seen an aircraft before 1941, performing complex technical work with extraordinary precision. A riveter might install thousands of rivets per shift, each one requiring proper hole alignment, correct rivet selection, precise tool positioning, and proper pressure application. After months of practice, skilled riveters developed almost unconscious competence. The rivet gun became an extension of their body. The sound of properly set rivets became recognizable. Mistakes became rare. Inspectors developed similar expertise. They could spot a poorly set rivet by sight from 10 feet away. They knew the sound of proper hydraulic system operation. They recognized when electrical connections weren't properly secured. This expertise wasn't documented in manuals. It lived in the workers themselves, accumulated through thousands of repetitions and shared through informal mentorship. But Willow Run was just one factory. Across America, the industrial transformation was total and unprecedented. Boeing's plants in Seattle turned out B-17 flying fortresses. Consolidated's factories in Fort Worth and San Diego built more B-24s. Douglas Aircraft produced bombers and transports. North American Aviation manufactured B-25 Mitchells and P-51 Mustangs. Lockheed built P-38 Lightnings. Republic Aviation's factories churned out P-47 Thunderbolts. Grumman built naval fighters. The list extended across the entire country. The scale was staggering. Employment in the aircraft industry rose from 100,000 workers in 1940 to more than 2 million at the war's peak. Nearly 300,000 military aircraft were produced from July 1940 through August 1945. The combined weight of all airframes and spare parts exceeded £2.8 billion. The cost approached $45 billion, nearly one-fourth of America's total munitions spending. The numbers weren't just impressive, they were decisive. In 1941, the first full year of war production, America built 19,433 military aircraft. Germany produced 11,424. Japan built 5,088. The American advantage was already visible, but it was just beginning. By 1942, American production reached 48,000 aircraft. Germany managed 15,000. Japan produced 9,000. The gap was widening. In 1944, American factories built 96,369 military aircraft. That single year's production exceeded Japan's entire wartime output. Germany, despite desperate efforts to increase production, built 39,807 aircraft in 1944. The numbers told a story of industrial capacity that the Axis powers couldn't match and couldn't counter. Consider the specific types. The B-24 Liberator became the most produced heavy bomber in history, with 18,493 built. Nearly half came from Willow Run. The B-17 Flying Fortress saw 12,731 produced. The P-47 Thunderbolt reached 15,636 aircraft. The P-51 Mustang totaled more than 14,000. Each type represented not just numbers, but capability. These weren't training aircraft or obsolete designs. These were frontline combat aircraft incorporating the latest technology. The industrial advantage extended beyond simple numbers. American aircraft were, on average, larger and more complex than Axis designs. A typical single-engine fighter required less material and labor than a four-engine heavy bomber. America produced more four-engine bombers than Germany and Japan combined. American factories built 31,694 four-engine bombers during the war. Germany managed about 6,000 four-engine aircraft. Japan's four-engine production was negligible. The implications for the war were profound and immediate. Strategic bombing campaigns against Germany required massive formations of heavy bombers. By 1944, the 8th Air Force could launch 1,000-plane raids against German industrial targets. The bombers came in waves protected by long-range fighters. German defenses, despite desperate efforts, couldn't stop them all. The damage was cumulative and crushing. Oil refineries were destroyed. Aircraft factories were bombed. Transportation networks were disrupted. Germany's war economy was systematically dismantled from the air. In the Pacific, American aircraft production enabled a different kind of dominance. Naval aviation became the decisive factor in the Pacific War. The aircraft carriers that turned the tide at Midway in June 1942 carried American-built fighters and dive bombers. Douglas SBD Dauntless dive bombers operating from USS Enterprise, USS Yorktown, and USS Hornet sank 4 Japanese carriers in a single day. That engagement fundamentally altered the Pacific War's trajectory. Japan lost carriers they couldn't replace. America lost carriers it could. That differential defined everything that followed. As the war progressed, American production allowed the Navy to replace losses and expand the fleet continuously. New Essex-class carriers were commissioned at a pace Japan couldn't match. By 1945, the United States operated 17 fleet carriers and more than 70 escort carriers. Japan, despite launching the war with a formidable carrier force built over 2 decades, built only 6 additional carriers after Midway. 3 were sunk before becoming operational. The industrial gap made victory inevitable because the mathematics were inexorable. Consider the strategic bombing campaign against Germany in concrete terms. In 1944, the 8th Air Force based in England could launch 1,000-plane raids against German industrial targets, 1,000 B-17s and B-24s, each carrying several tons of bombs, escorted by hundreds of P-51 Mustangs and P-47 Thunderbolts. The formations stretched for miles. The bombardiers could see target cities from 50 miles away. German defenses, despite desperate efforts, couldn't stop them all. The bombers came in waves. The first wave targeted fighter defenses, suppressing German interceptors and flak batteries. Subsequent waves focused on primary targets: oil refineries, aircraft factories, ball-bearing plants, railroad marshalling yards. The damage was cumulative and crushing. A factory damaged in January's raid, partially repaired by March, would be hit again in April. The Germans couldn't rebuild faster than Allied bombers could destroy. The statistical reality was grim for German industry. Oil production, which peaked at about 300,000 tons per month in early 1944, fell to less than 100,000 tons by September. By December 1944, it had collapsed to approximately 26,000 tons. German tanks and trucks sat immobile for lack of fuel. The Luftwaffe grounded squadrons of fighters because aviation fuel didn't exist. The strategic bombing campaign didn't win the war alone, but it made winning possible by systematically dismantling Germany's war economy from the air. American aircraft losses in these operations were substantial. Thousands of bombers and fighters destroyed. Tens of thousands of airmen killed or captured. But American factories replaced aircraft faster than combat destroyed them. A B-17 shot down over Germany in July could be replaced by August, often sooner. The replacement aircraft would be newer, incorporating lessons from combat experience, better armor around vulnerable points, improved defensive armament, enhanced engine reliability. Germany couldn't match this replacement rate. A Messerschmitt Bf-109 destroyed in combat might take months to replace because the factory that built its engines had been bombed, or the aluminum refinery that supplied the factory, or the transportation network that moved components. American strategic bombing created cascading disruption that German industry couldn't overcome. The psychological impact on German defenders was corrosive. Luftwaffe pilots knew that shooting down American bombers was futile in the larger strategic sense. More bombers would come tomorrow, and the day after, and every day thereafter. German fighter pilot diaries from late 1944 document the spreading despair. They were fighting an enemy that couldn't be defeated through conventional attrition, because the enemy's production capacity made attrition irrelevant. The production advantage also enabled something unprecedented. America didn't just equip its own forces. Through Lend-Lease, American factories supplied allies with thousands of aircraft. The Soviet Union received more than 14,000 American aircraft. Britain received thousands more. Commonwealth nations operated American fighters and bombers. Even China received American aircraft support. No other nation could simultaneously equip its own military while supplying allies on this scale. The human cost of this industrial miracle deserves recognition. Workers died in industrial accidents. The production pace was relentless. Shifts ran around the clock. Holidays were rare. The pressure was constant, but most workers understood what was at stake. They read news from the Pacific. They followed reports from Europe. They knew their work mattered. Every aircraft that rolled off the assembly line was a weapon that might save American lives. Every bomber meant one more mission against the enemy. Every fighter meant better protection for ground troops. Maria Santos worked the night shift at Douglas Aircraft's Long Beach plant. She assembled cockpit instruments for A-20 attack bombers. Her brother was fighting in North Africa. Her cousin served on a Navy destroyer in the Pacific. Every night, when she installed the final instrument panel and signed off on another completed aircraft, she thought about them. She thought about pilots who would rely on these instruments. She thought about whether her work would make a difference. It did. It all did. The economic impact of this industrial mobilization extended far beyond aircraft production. The transformation touched every sector of American society. Unemployment, which had reached 17% in 1939, effectively disappeared. The labor shortage became so acute that factories actively recruited women, minorities, and anyone who could work. Wages rose. Purchasing power increased. The Great Depression, which had defined the 1930s, ended not through government programs, but through wartime industrial expansion. The technical innovations developed for aircraft production transformed post-war industry. Precision manufacturing techniques refined for aircraft assembly found applications in consumer goods. Organizational systems developed to coordinate massive supply chains influenced corporate management for decades. Training programs that turned ordinary workers into skilled technicians became models for vocational education. The industrial lessons learned building aircraft during the war shaped American manufacturing through the rest of the 20th century. But the most profound impact was psychological. America proved to itself and the world that democratic societies could mobilize industrial power as effectively as totalitarian regimes. The Nazi propaganda that democracy was weak and decadent crumbled before the evidence of American production. Hitler had dismissed Roosevelt's 50,000 aircraft goal as propaganda. By 1944, American factories were producing 100,000 aircraft per year. The skeptics had been wrong. The critics had underestimated both American industrial capacity and American determination. Donald Douglas, founder of Douglas Aircraft Company, captured this truth succinctly. Here's proof that free men can outproduce slaves. The statement wasn't just rhetoric, it was observable fact. German factories relied increasingly on forced labor as the war continued. Concentration camp inmates worked in aircraft plants under brutal conditions. The efficiency was terrible. The quality was poor. Sabotage was common. By contrast, American workers chose their employment. They were paid fair wages. They understood why their work mattered. The productivity difference was measurable and decisive. By war's end, the statistics were overwhelming. America produced 300,317 military aircraft from January 1, 1940, through August 14, 1945. Germany, despite years of preparation and early industrial advantages, managed approximately 119,000 aircraft over the war's entire duration. Japan produced roughly 76,000 aircraft. The combined Axis production of Germany, Japan, and Italy totaled approximately 198,000 aircraft. America alone exceeded that by more than 100,000 planes. The aircraft were just part of a larger industrial miracle. American factories produced 86,000 tanks during the war. Compare that to Germany's 67,000 and Japan's 2,500. American shipyards built 5,200 large ships and thousands of smaller vessels. In 4 years, American industrial production doubled. The nation that had ranked 18th in military power in 1939 became the strongest military force in world history. By 1945, Colonel Paul Tibbets climbed into a B-29 Superfortress on August 6, 1945. The aircraft beneath him represented the pinnacle of American industrial and technological achievement. The B-29 was the most advanced bomber in the world, more sophisticated than anything Germany or Japan had produced. Each one cost more than $1 million to build. The entire B-29 program cost more than the Manhattan Project that created the atomic bomb Tibbets carried in his bomb bay. The mission over Hiroshima that morning demonstrated the totality of American industrial advantage. The bomber was American. The atomic weapon was American. The long-range capability that put Tibbets over Japan came from American engineering and American industrial capacity. The war ended not just because of the atomic bomb, but because American industry had produced an arsenal so vast and so technologically advanced that Japan had no answer. Robert Johnson, the test pilot who had flown one of the first B-24s off Willow Run's assembly line in 1942, survived the war. He returned to civilian life and watched as the massive factory that had employed 42,000 workers at its peak closed down. Willow Run produced its last B-24 in June 1945. By 1945, only 7,400 workers remained on the payroll. The factory that had symbolized American industrial might during the war was suddenly obsolete. The facility didn't disappear. Kaiser Frazer Corporation bought it and produced automobiles there for years. Later it housed General Motors transmission production. But the symbolic moment had passed. The factory that had produced nearly 9,000 B-24 Liberators, that had proven mass production could build anything, that had employed Rosie the Riveters, who became icons of American industrial power, that factory returned to making civilian products. The women who had built aircraft faced their own transitions. Many were laid off as returning veterans reclaimed factory jobs. Some were given increasingly difficult assignments designed to encourage them to quit. The The social pressure to return to traditional roles was intense, but something had changed. These women knew what they were capable of. They had operated complex machinery. They had read technical drawings. They had built 4-engine bombers. That knowledge, that experience, that capability, it didn't disappear just because the war ended. The lessons of American aircraft production during World War II extended far beyond the immediate military victory. The industrial mobilization proved that democratic societies could match and exceed totalitarian productivity. The inclusion of women in the industrial workforce challenged assumptions about gender roles that would later fuel the women's rights movement. The organizational innovations and mass production techniques developed for aircraft manufacturing influenced American industry for generations. Perhaps most importantly, the aircraft production miracle demonstrated the profound connection between industrial capacity and military power in modern warfare. Technology matters, training matters, tactics matter, but ultimately, wars between industrial powers are won by production. The nation that can build more weapons, replace losses faster, and supply its allies while equipping its own forces, that nation has an insurmountable advantage. Germany and Japan both understood this too late. German military planners knew American industrial capacity was greater than their own, but they believed American society was too divided and too comfortable to mobilize effectively. They were wrong. Japanese military leaders hoped that early victories would force America to negotiate. They underestimated American resolve and American industrial capability. By 1943, both Axis powers understood they were in a production war they couldn't win. The human stories behind the statistics deserve final recognition. Rose Monroe, the Rosie the Riveter who built B-24s at Willow Run, continued working in aviation for years after the war. She became a pilot flying her own aircraft. Eleanor Otto, who began working as a riveter after Pearl Harbor, continued building aircraft well into her 90s, finally retiring from Boeing's C-17 plant in Long Beach. These women, and hundreds of thousands like them, didn't just build aircraft. They proved capability that had been doubted and questioned for generations. The factory workers who turned out 300,000 aircraft in 4 years came from every background. Farm kids from Iowa, factory workers from Detroit, women from Kentucky, African Americans from the South who fled sharecropping for industrial wages, recent immigrants who saw defense work as both economic opportunity and patriotic duty. They worked together in factories that ran continuously, building weapons for a war many of them would never see directly. Charles Sorensen's sketch on Hotel del Coronado, notepaper, became reality because thousands of engineers translated vision into technical specifications. Albert Kahn's architectural genius created factories of unprecedented scale. Tool and die makers created fixtures with tolerances measured in 10,000ths of an inch. Quality inspectors rejected substandard work, even under pressure to maintain production schedules. Logistics specialists coordinated supply chains spanning the continent. Each role was essential. Each contribution mattered. The B-24 Liberator that test pilot Robert Johnson flew in September 1942 was just the beginning. By war's end, American factories had produced 300,000 aircraft. The number almost defies comprehension. Imagine those aircraft lined up wingtip to wingtip. They would stretch for thousands of miles. Stack them by weight and you have nearly 3 billion pounds of aluminum, steel, rubber and glass transformed from raw materials into precision machinery. Every one of those aircraft required thousands of man-hours to build. Every one represented materials that had to be mined, refined, shaped and assembled. Every one required instruments, engines, radios, weapons and countless other components. The supply chain extended through the entire American economy. Rubber plantations in South America, aluminum refineries in the Pacific Northwest, steel mills in Pennsylvania, oil refineries in Texas, all connected through a logistics network that became one of the great organizational achievements in human history. The enemy understood the implications. By 1943, German and Japanese military planners knew the war was lost. They knew it because they understood production statistics. They knew that American factories were producing more aircraft every month than they could produce in a year. They knew that losses they couldn't replace were routine for American forces. They knew that the material advantage was so overwhelming that tactical skill and individual courage couldn't compensate. Albert Speer, Germany's Minister of Armaments, wrote after the war about his realization that Germany had lost. It wasn't a single battle. It wasn't a particular strategic failure. It was the relentless arithmetic of production. American bombers that were shot down today were replaced by tomorrow. German fighters destroyed in combat took weeks or months to replace. The mathematics were inexorable. The industrial advantage America had built through 4 years of transformation couldn't be countered or overcome. The legacy of those 4 years extended far beyond 1945. The industrial infrastructure built for aircraft production converted to civilian uses. The Boeing Company, which had built B-17s during the war, became the world's largest commercial aircraft manufacturer. Douglas Aircraft's experience building military transports led to commercial jets that revolutionized air travel. North American Aviation's fighter production expertise evolved into aerospace engineering that put men on the moon. The technological capabilities developed for military production became the foundation for post-war American industrial dominance. The human legacy was equally profound. The women who had built aircraft didn't forget what they'd accomplished. Their daughters and granddaughters grew up hearing stories about Rosie the Riveter, who was grandmother, who built bombers, who proved that capability wasn't limited by gender. The African Americans who had fled the South for defense jobs didn't return to sharecropping. They settled in Detroit, Los Angeles, Seattle, urban industrial centers, where their wartime experience translated to post-war opportunities. The social transformations enabled by wartime industrial mobilization continued reverberating through American society for generations. Stand today at the site of Willow Run, and you see automotive proving grounds for autonomous vehicle testing. The massive factory where Ford built B-24s has been mostly demolished. A small section remains, preserved as a museum housing the Yankee Air Museum's collection. But the physical structure was never truly the point. The building was just shelter for a process. What mattered was what happened there. What mattered was the transformation it represented. The point was proving that free societies could mobilize industrial power as effectively as dictatorships. This wasn't obvious in 1940. Many observers believed totalitarian systems possessed inherent organizational advantages: central planning, directed labor, elimination of competitive waste. The fascist powers themselves believed this, which partially explains their willingness to wage war against nations with larger economies. They were wrong. Catastrophically, decisively wrong. The 304,000 aircraft produced by American factories over 4 years weren't just weapons. They were proof that democratic industrial society, when properly organized and motivated, could achieve production levels that exceeded centrally planned economies. Free workers, properly compensated and understanding why their work mattered, outproduced forced labor by margins that shocked even Allied planners. Donald Douglas, founder of Douglas Aircraft Company, crystallized this truth after the war. Here's proof that free men can outproduce slaves. The statement wasn't rhetorical flourish. It was observable fact documented in production statistics that couldn't be disputed. German factories relied increasingly on forced labor as the war continued. Concentration camp inmates, prisoners of war, and conscripted workers from occupied territories worked in aircraft plants under brutal conditions. The efficiency was terrible. Quality was inconsistent. Sabotage was common. German planners complained constantly about production shortfalls they attributed to unreliable forced labor. American workers, by contrast, chose their employment. They were paid market wages, often good wages by Depression-era standards. They understood their work contributed to defeating fascism and protecting democracy. The productivity difference was measurable in every metric: hours per aircraft produced, defect rates, on-time delivery, innovation in manufacturing processes. American workers, motivated by purpose and properly compensated, achieved productivity that forced labor could never match. The legacy of those 4 years extended far beyond the immediate military victory. The industrial infrastructure built for aircraft production converted to civilian uses when peace returned. The Boeing Company, which had manufactured thousands of B-17 Flying Fortresses during the war, became the world's largest commercial aircraft manufacturer. Their engineers, who had designed strategic bombers, created the 707 jetliner that revolutionized commercial aviation. The technical expertise, organizational capacity, and manufacturing capability developed for military production became the foundation for post-war American aerospace dominance. Douglas Aircraft's wartime experience building military transports led directly to commercial airliners that transformed global travel. The DC-6 and DC-7, both direct descendants of wartime transport designs, made long-distance air travel practical and affordable for ordinary citizens. North American aviation's fighter production expertise evolved into aerospace engineering that contributed to the Apollo program. The systems engineering, quality control, and project management techniques developed for aircraft production became templates for putting humans on the moon. The human legacy was equally profound, though more difficult to quantify. The women who had built aircraft didn't forget what they'd accomplished. When peacetime employers tried to push them back into traditional roles, many resisted. They knew their capability. They'd proven it to themselves and everyone else. That knowledge, that demonstrated competence, couldn't be erased by returning to social conventions. Their daughters and granddaughters grew up hearing these stories. Stories about grandmother who built B-24 bombers, who operated complex machinery, who earned the same wages as men for the same work, who proved that gender had nothing to do with technical capability. These stories shaped expectations and ambitions for subsequent generations. The women's rights movement of the 1960s and 1970s drew strength from the wartime demonstration that women could perform any work given training and opportunity. The African Americans who had fled southern sharecropping for defense industry jobs didn't return to agricultural servitude when peace came. They settled permanently in northern and western industrial cities, Detroit, Los Angeles, Chicago, Seattle. Their wartime wages had provided economic foundation for establishing urban lives. Their children attended better schools, gained better educations, accessed opportunities that Southern segregation had systematically denied. The Great Migration, accelerated by defense industry employment, fundamentally transformed American racial demographics and eventually undermined Jim Crow segregation. The technical innovations developed for aircraft production rippled through American manufacturing for generations. Precision measurement techniques refined for aircraft assembly found applications in consumer electronics. Statistical quality control methods developed to ensure aircraft reliability became standard practice across industries. Just-in-time inventory management, which Ford pioneered to coordinate Willow Run's complex supply chains, evolved into logistics practices that define modern manufacturing. The organizational lessons proved equally valuable. Coordinating production involving thousands of suppliers required communication and management systems that didn't exist in 1940. Ford developed these systems through necessity. They created tracking mechanisms for thousands of components moving through hundreds of facilities. They developed scheduling algorithms to ensure subassemblies arrived precisely when needed. They pioneered computer-assisted logistics before computers existed, using punch cards and mechanical tabulating machines to manage complexity that exceeded human capacity. These organizational innovations, developed under wartime pressure, became foundation for post-war corporate management. The systems thinking required to build 300,000 aircraft influenced how American companies organized production for decades. Project management as a discipline emerged from wartime production challenges. Systems engineering, as a formal methodology, developed from the necessity of coordinating thousands of interdependent components. But perhaps the most enduring legacy was psychological. America proved to itself what it was capable of achieving. A nation still recovering from economic depression, a nation whose military ranked 18th in global power, transformed itself in 4 years into the strongest industrial power in human history. That transformation happened because ordinary people accomplished extraordinary things. Factory workers who'd never seen an aircraft before 1941 built them by the thousands. Engineers solved technical problems that had seemed unsolvable. Managers coordinated production at scales never attempted. Women proved they could do any work men could do. The skeptics had been wrong. The critics who said 50,000 aircraft per year was impossible were wrong. The aviation experts who said bombers were too complex for mass production were wrong. Hitler's advisors who dismissed Roosevelt's promises as propaganda were wrong. The doubters underestimated what Americans could accomplish when challenged. They underestimated the industrial capacity lying latent in a country that had built 15 million automobiles before turning that capability toward military production. Robert Johnson, the test pilot who had flown one of the first B-24s off Willow Run's assembly line in September 1942, survived the war. He returned to civilian aviation and watched as the massive factory that had symbolized American industrial might was gradually repurposed and eventually mostly demolished. The building that had employed 42,000 workers at its peak fell silent. The assembly line, where a bomber had rolled out every 63 minutes, ceased operation. But what happened there couldn't be demolished. What was proven there remains proven. The capability demonstrated at Willow Run and thousands of other factories across America during those 4 years revealed truths about human capacity and democratic industrial society that subsequent generations inherited. The last B-24 rolled off Willow Run's assembly line in June 1945. Workers clocked out for the final time. The machines fell silent. But what they had accomplished, that echo continues. It echoes in every aerospace factory where workers build aircraft using techniques pioneered during the war. It echoes in every industrial transformation where organizations convert capability toward new purposes. It echoes in the understanding that achievement once proven cannot be denied or forgotten. They built 304,000 aircraft when the world said it couldn't be done. They outproduced the combined industrial might of Germany and Japan when critics said American democracy was too weak, too disorganized, too comfortable to mobilize effectively. They proved that free people, working together toward shared purpose, can accomplish anything. That lesson transcends the specific historical moment. It speaks to fundamental questions about human capability and social organization. Can democratic societies match totalitarian efficiency? Can free workers outproduce forced labor? Can commercial industrial capacity convert rapidly to military production? Can ordinary people master complex technical work when properly trained and motivated? The answer to all these questions was written in aluminum and steel and sweat across 4 extraordinary years. The answer was 304,000 aircraft. The answer was victory achieved through production that overwhelmed the enemy not through superior tactics or better generals, but through sheer industrial capacity that couldn't be matched or countered. Rose Monroe, who had built B-24s at Willow Run, continued working in aviation for decades after the war. She learned to fly and piloted her own aircraft for years. She never forgot what she'd accomplished during those war years. Neither did America. The Rosie the Riveter icon she helped create became symbol for generations of women who refused to accept artificial limitations on their capability. Marie Kalk, who had walked into the Glen L. Martin plant in Omaha in October 1941, told her children and grandchildren about building bombers, about proving what she could do, about wages that gave her economic independence, about discovering capability she'd never known she possessed. Her granddaughter became an aerospace engineer, working on systems that descended directly from technologies developed during the war. The legacy was direct and personal and profound. Charles Sorensen's sketch on Hotel del Coronado notepaper became Willow Run. His vision of mass-produced 4-engine bombers, dismissed as impossible fantasy by aviation experts, became reality that produced nearly 9,000 B-24 Liberators. He proved that systematic thinking and engineering discipline could transform any manufacturing challenge, regardless of complexity. His principles, standardization, modular design, precision tooling, systematic assembly, became foundation for modern manufacturing across every industry. The 304,000 aircraft represented more than weapons. They represented capacity, American capacity, human capacity, the capacity of free societies to mobilize, organize, and achieve production levels that exceeded what any nation had accomplished. That capacity, once demonstrated, changed how the world understood industrial power and democratic possibility. Germany and Japan had underestimated this capacity. They believed American society was too individualistic, too commercially focused, too comfortable to mobilize for total war. They calculated that America's distance from the fighting would weaken resolve. They assumed democratic politics would paralyze decision-making. They expected labor disputes and corporate competition to prevent effective coordination. They were wrong about all of it. American individualism proved compatible with coordinated industrial effort when purpose was clear. Commercial focus meant existing industrial capacity could be redirected rather than built from scratch. Distance from fighting meant American factories operated without bombardment disruption that degraded Axis production. Democratic politics produced leaders like Roosevelt who understood industrial power's strategic importance. Labor and management cooperated when both understood what was at stake. The result was 304,000 aircraft. More than Germany and Japan combined. More than critics believed possible. More than enough to win the war and change history. But also more than enough to prove what Americans could accomplish. More than enough to demonstrate that free people, properly organized and motivated, can outproduce any forced labor system. More than enough to show that democracy's supposed weaknesses, individual liberty, distributed decision-making, voluntary cooperation, were actually sources of strength when channeled toward common purpose. This is the story that deserves remembering. Not just the numbers, though the numbers are staggering. Not just the victory, though the victory was total. But the human achievement those numbers represent. Ordinary people doing extraordinary work. Farmers becoming factory workers. Women becoming riveters. Engineers solving impossible problems. Managers coordinating complexity that exceeded previous experience. All of them together. Building 304,000 aircraft and proving what Americans could accomplish when challenged. The echo of that achievement continues because the lessons remain relevant. Industrial capacity matters. Training people properly matters. Organizing work systematically matters. Paying fair wages matters. Understanding purpose matters. Free people, given opportunity and purpose, can accomplish anything. That truth, proven across 4 years in factories across America, remains true today and will remain true for generations to come.